Namaskar, my dear friends. Let us continue probability. So, what we have done is we have seen theory of conditional events under probability. Now we'll solve few questions based on the gate that has been asked in last years. So, let us say question 1. We have two independent events like X and Y are independent events with probability given that probability of X is given as 0.4 and probability of X union Y complement is given as 0.7. It means it is given that probability of X union not Y is 0.7. Find probability of X union Y. So this is the thing that we have to find out. Okay. So can you take a moment and try to find it out? So you guys already know, let us say, you guys already know that probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B, right? And since A and B are independent, so you can write it down. Probability of A intersection B is equal to probability of A into probability of B. So in that fashion, if I know probability of A, probability of B, then it is very easy for me to find out probability of A intersection B if A and B are independent. So similar to that, we have probability of X. If we find out probability of Y, then it is very easy for me to find out what is the probability of X union Y. So that is our aim to do that, right? So in that fashion, can we do probability of X union probability of X union Y complement will be nothing but this was given, right? So this is nothing but what we can write it down, probability of X plus probability of Y complement minus probability of X intersection Y complement. Okay. So in that fashion, this is going to be 0.7. You know already that this was given as 0.7. From here, I can write it down as probability of Y complement because we don't know that minus probability of X intersection Y complement is equal to 0.7 minus probability of X because probability of X I have taken right side. Now what do we do? From here we are going to get probability of Y complement minus probability of X intersection Y complement is equal to 0.7 minus 0.4, that is 0.3. Okay. Now you know already that X and Y are independent. It means X and Y complement will also be independent, right? So in that case, I can write it down. Probability of Y complement minus probability of X into probability of Y complement because A intersection B is probability of A into probability of B will be 0.7, 0.3. Now I can take it probability of Y complement common into 1 minus probability of X will be equal to 0.3. So from here we are going to get probability of Y complement into 1 minus, you know already probability of X was how much? It was 0.4. So this will become 0.4 equal to 0.3. So from here we are going to get probability of Y complement is equal to 0.3 divided by 1 minus 0.4, that is 0.6, that is going to be 3 by 6, it is 0.5. So now you know that we have probability of Y complement as well, which is going to be 0.5. So from this, can we write it down? My probability of Y will be what? 1 minus probability of Y complement. So that is going to be 1 minus 0.5, which is going to be 0.5. Okay. Now let us do that. We can write it down. What was the probability that was needed? Probability of X union Y. So that will be written as probability of X plus probability of Y minus probability of X intersection Y. And you know X and Y are independent. It means I can write it down as probability of X plus probability of Y minus probability of X into probability of Y. And all these four values we know already. Probability of X is 0.4 plus probability of Y is 0.5 minus probability of X is 0.4 into 0.5. So this is going to be 0.9 minus Panchamka bis 0.2. So that is going to give me 0.7. So this was the answer that was for the required probability of X union Y. Probability of X union Y is 0.7. Understood? Any question? All right. Let us take another question. So the question is, we have two events E1 and E2, okay? For two events E1 and E2 with probability of E1 is equal to 1 by 2, probability of E2 is equal to 1 by 3, and probability of E1 intersection E2 is equal to 1 by 5. Which of the following statement is correct? Which of the following statement is correct? So this was asked in last year GATES. Okay. So you can say option 1 is probability of E1 union E2 is equal to 2 by 3. Number B, E1 and E2 are independent. E1 and E2 are independent. C is E1 and E2 are not independent. And D is probability of E1 given E2 is equal to 4 by 5. So take some time and try to find out which one of them is true. Alright, so why don't we do one thing? We have probability of E1, probability of E2, and probability of E1 intersection E2, both are there, right? So do you think like we have events A and B are independent? You have seen, right? When probability of A intersection B is equal to probability of A into probability of B. So why don't we do one thing here, that if my probability of E1 intersection E2 is equal to 1 by 5, is it equal to probability of E1 into probability of E2? If it is yes, then we can say these two are independent, right? So what is probability of E1? 1 by 2. What is probability of E2? 1 by 3. It is going to be how much? 1 by 6, which is not equal to probability of E1 intersection E2. It means I can say E1 and E2 are not independent. Okay. So I can say option C, which is E1 and E2 are not independent. That's the answer. Understood? Let's take another question. This question was asked in last year's GATE. Suppose A and B are two independent events. A and B are two independent events. Okay. Which of the following is false? Options are probability of A is not equal to 0. B is probability of B is not equal to 0. C is probability of A intersection B is equal to probability of A into probability of B. And D is probability of A union B is equal to probability of A plus probability of B. Yes, please. So just try to find out which of them is false. So as you know that probability of A and probability of B cannot be together 0. Okay. So that's the reason, and you can see these are two independent events. It means you know already that probability of A and probability of B cannot be together 0, and at the same time probability of A intersection B is going to be probability of A into probability of B, right? So in that case you will see that probability of A union B is never going to be probability of A into probability of B. Why? Because these two are independent event, and we have probability of A union B is equal to probability of A into plus probability of B minus probability of A intersection B, which is going to give me probability of A plus probability of B minus probability of A into probability of B. And that's the reason this particular like equation cannot be true. So this is the right answer. This is my wrong statement. Understood? Because these two are independent, it means this is non-zero, this is satisfied, and these two are non-zeros probably. Okay. Let's take another question. The question is, probability of passing the exam, probability of pass is 0.2, and probability of pass given 90 or above is 0.05. Like you are passing is 0.2, and you are passing as well as getting more than 90 or is 0.05. What is the probability? What is the probability that you have passed, like you will get 90 when you have passed? Given that a student has passed the examination, and we have to find out that he has got more than 90. Okay. So how shall we do that? If we try to solve this question, it's very easy. It is conditional probability, right? So you know already that probability of A given B is equal to probability of A intersection B divided by probability of B, right? So if I try to find out probability of 90 given a student has passed the examination, that will be probability of 90 intersection pass divided by probability of pass, right? So from here we are going to get what? You know already that probability of 90 intersection pass is nothing but what? 0.05, because he has passed. Oh, sorry. Actually, this was given probability of pass intersection 90. Okay. So probability of 90 intersection pass or pass intersection 90, both are same. So this is going to be 0.05 divided by probability of pass, that is 0.2. So if you see that, you are going to get 5 by 20, that is 1 by 4. Understood? So the probability that the student will get 90 given that he has passed is 1 by 4. Okay. Let's take another question. The question is, there are 3 vendors. Okay. So 3 vendors were asked to supply a precision component. Okay. 3 vendors were asked to supply a very precision component. Okay. The respective probabilities of their meeting strict design specification, the probability or the respective probability of their meeting strict design specification are 0.8, 0.7, 0.5. Each vendor supplies one component. Okay. The probability that out of 3 components, okay, the probability that out of 3 components, at least one will meet the design specification. Meet the design specification is what? So we have to find out that these 3 vendors, their design specification probability is 0.8, 0.7 and 0.5, and each of them has supplied, let's say, one component. Then those components will meet the design specification. I mean, one of them will meet design specification is what? Okay. So that's the question that we have to understand, right? So let us say we have 3 vendors, which is A, B and C, and their probability of meeting the design specification is given as 0.8, 0.7 and 0.5. Okay. So not meeting will be how much? 1 minus 0.8, that is 0.2, 0.3, 0.5. So that will be not meeting. So this is the data that we have. Now if one of them is meeting the specification, then our aim is to actually find out probability of A union B union C. How one of them or all of them or more than one of them is meeting the spec, right? So for that, can we do one thing? Probability of A union B union C is equal to, what is the relation? Probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. Understood? Now, as you know that these three vendors A, B, C are independent, right? They are not related to each other. I mean, if A is making correct, B can make correct or not correct doesn't depend on A, right? So you can say that A, B, C are independent. So if they are independent, you know already that probability of A intersection B will be probability of A into probability of B. So that relation we will use quickly. So why don't we do quickly? What is probability of A? 0.8 plus 0.7 plus 0.5 minus AB. So A intersection B is A into B, that is going to be 8 sate 56, 0.56 minus BC. BC is 0.7 into 0.5, that is 0.35 minus CA. CA is 0.4. 8 into 0.8 into 0.5, that is 8 5 40, 0.4 plus ABC probability of intersection A intersection B intersection C, that is going to be all these three multiplications. So that will give me how much? 8 5 40, 4 7 28, 0.28. Now you solve this and get the value. So if you solve this, you are going to get 8 7 15 5 20, right? So 2 minus 2.28 minus this. That is going to give me 0.97. So this is one of the method to get this. Why don't we do one thing? We'll apply another method. Our aim is to find out probability of A union B union C. Can we do that 1 minus probability of A union B union C complement? This is also one method. Like what is the probability that this does not happen? That is probability of A union B union C complement, right? And you know you know this, that A, B, C were independent. It means 1 minus probability of, this can be written as A complement intersection B complement intersection C complement. Okay, and since they are independent, so I can write it down 1 minus probability of A complement into probability of B complement into probability of C complement. And from here we can write it down 1 minus, see, probability of A is 0.8, so probability of not A is 0.2. So not once I will write it down. So what will happen? What will happen is probability of A complement is 0.2 multiplied by 0.3 multiplied by 0.5. So that is 1 minus 2 tiya 6 35, 0.3, that is, sorry, 0.03. So that is 0.97. So this is the required probability that one of the component will pass the design specification from any of the vendors given is 0.97. So all right, with this we have completed our conditional probabilities. Now we'll move to the next topics of probabilities like total probability and Bayes theorems and all those things in our next session. Thank you.